All right, so in this next one, we will look at fluid pressure. We have an object that's underwater, and basically what happens is that all of the fluid that's up above the item, whether it's a submarine or whatever, all of that is collecting and working together and pushing down on top of the object. And so we end up with a variation of our formula from before. What happens is because all of that water is working together, I'm going to leave some space in front and come back to it. We look at the distribution of the water, basically how it packs into a certain amount of space. So that's going to involve density. Then we need gravity to turn this into an actual force. And then in order to basically see how much total water we're dealing with, we put the height in. And so you might think of this as depth, but if you were say in a submarine down that far underwater looking up, then think of how far it would be to the surface. So that's kind of what we're thinking here. Sometimes the rho and the gravity are combined to make a weight density instead of a mass density. We'll see that a little bit later on. But from here we can basically just start plugging in. So in the question is our only number. We got 158.22 meters. Density of water, if we look around at our different units, so I'm going to go ahead and put gravity in first and leave a space. We're trying to get to newtons per square meter, so I want something that's got either newtons in it or something that can turn into newtons and meters, and so I don't want to use the number from before. I don't want to use units like grams and milliliters like we had earlier. In this case, and this is on your formula sheet, one of our options, 1,000 kilograms per cubic meter, is actually going to be our best fit because the kilograms and the meters per second squared from over here will make the newtons, and then the cubic meters on the bottom will cancel partially and give the square meters. And then that means from here, all we need to do is just multiply these together. This time we get an even bigger number. It's over 1.5 million. Because these are pascals, it's still relatively big, but it's not as massive as it seems when it's millions like that.